Students, we will discuss about process capability ratio and process capability ratio for an off-centered process. So PCR or CP is given by USL minus LSL by 6 sigma. So where USL is the upper specification limit, LSL is the lower specification limit, and sigma is the standard deviation. When you want to find the PCR for an off-centered process, it is called PCRK or CPK. So CPK is the minimum of PCR upper, PCR lower, where PCR upper is given by USL minus mu by 3 sigma and PCR lower is given by mu minus LSL by 3 sigma. Let us discuss with an example. This component has to be produced in mass quantities. The drawing size is 12 minus 0 minus 0.06. So from this, the upper specification limit is found as 12 mm and the lower specification limit 12 minus 0.06 is 11.94. The process capability study gives a result of mean of 11.97, standard deviation of 0.01. So this is the case A. Okay. So from this, the PCR value is found as USL minus LSL by 6 sigma, which is equal to 1. In case B, the process capability study gives a result of a mean of 11.98, a standard deviation of 0.01. The PCR value for this case B also equal to 1. Case C, the process capability study gives a result of mean of 12 and standard deviation of 0.01. The PCR for this case also 1. So the PCR for all the three cases is found to be 1. For the first case, the mean is 11.97. It is coinciding with the drawing mean. See, this is the process, the distribution curve for the process, and this is USL and LSL. So the process is centered. For the case B and case C, the process is off-centered. How to identify whether the process is centered or off-centered? With the help of PCR and PCRK, we are going to discuss. So we have found the PCR for all the three cases. Let us find the PCRK. For PCRK, for case A, first we have to find the PCR upper. So PCR upper for case A is USL minus mu by 3 sigma. So it comes to 1. PCR lower for case A is mu minus LSL by 3 sigma. So which is also equal to 1. So the PCRK is minimum of PCR upper, PCR lower. So both are 1. So the minimum value is 1. So PCRK for the case A is 1. PCRK for the case B we are finding now. So PCR upper is 0.67. PCR lower is 1.3. So the PCRK is the minimum of these two. So which is equal to 0.67. For the case C, PCR upper is 0, PCR lower is 2. So the minimum of these two values 0. So the PCRK for the case C is 0. So we have found PCR and PCRK for each of the three different cases. For case A, the PCR is 1, PCRK is also 1. For case B, the CP or PCR is 1 and CPK is 0.67. For case C, CP is 1 and CPK is 0. So what we can understand from comparing these three different cases of process capability study results is that if the CPK and CP both are same, the process is centered. If the CPK is less than CP, the process is off center. So by comparing these two, Cp and Cpk for case B and Cp and Cpk for case C, we can identify that Cpk is less than Cp for both the cases. So both the cases are example of off-center process. So case A, where both Cp and Cpk are equal, so case A is an example for center process. Let us next we will discuss about the quality level, plus or minus 6 sigma quality level. If you want to maintain plus or minus 6 sigma quality level for a process, okay, you can expect a ppm defect of 3.4 parts per million. So this is graphically represented here. If you want to maintain 6 sigma quality level, the distance between the USL and LSL should measure 12 times sigma. And not only that, the process shift from the drawing mean, okay, should be limited to plus or minus 1.5 sigma on both sides. Let us discuss this with an example. The component shown in the figure has to be manufactured with a plus or minus 6 sigma quality level. What is the maximum allowed dispersion of the measured values from the drawing mean? To what extent the process mean can be allowed to drift on either side of the drawing mean? So this is the question. So let us find out the answer for the first question. The process mean is found like this. So USL minus LSL should measure 12 times sigma. So USL is 12 and LSL is 11.94, both are taken from the drawing, and it should measure 12 times sigma. In that case, what should be the value of sigma? Sigma is equal to 0.005. If you want to maintain 6 sigma quality level for managing this component, the process standard deviation should be equal to 0.005 or less than 0.005. And the process shift, okay, it should be limited to what level? So as per this graphical representation, the process shift should not be beyond 1.5 sigma on either side. So 1.5 sigma is equal to 1.5 into sigma value 0.005, it is coming to 0.0075. The drawing mean for the component is 11.97. So from the drawing mean of 11.97, okay, the mean should not deviate beyond, okay, 0.0075 on either side. So 11.97 minus 0.0075, it is 11.9625. On right side, 11.97 plus 0.075, it is 11.9775. So if you want to maintain 6 sigma quality level for managing this component, the standard deviation should be equal to 0.005 or less than 0.005. And the process mean should not be less than 11.9625 or it should not be more than 11.9775. So the process mean should not drift more than the allowed value of plus or minus 1.5 sigma. So if you maintain these two conditions, you can expect a 6 sigma quality level with a parts per million defect of 3.4 parts.